Hi, in this session we will be discussing about partitioned table, that is table with partitions. First of all, why should we go for partitioned table? What is the necessity of using partitioned table? See, these days we are doing the business across the globe with multiple countries, with multiple regions, with multiple time zones. Most of the businesses are going online. So the number of customers are increasing. The number of sales are increasing day by day, year on year, month on month. So when the business is increasing, the number of records which are coming to the transactional database is also increasing, due to which the size of the table is increasing a lot. The number of records will be huge in each table, in each transactional table. Let us take sales data. If it is online, if our business is online, the number of records will be more. If we take the banking, the number of transactions per day of any bank will be some crores of records. If we take telecom department, telecom domain, the number of calls made on each day will be crores or billions sometimes. The number of outgoing calls per day, number of incoming calls per day, even for a single SIM card, number of incoming calls and the number of outgoing calls will be, on average basis, it will be a minimum of 10. A minimum of 5 outgoing calls and 5 incoming calls per day for one SIM card. So when we have multiple customers and multiple vendors, telecom operators, so there will be huge number of outgoing calls and incoming calls. We need to track all these things in our transactional tables. So when we are storing all this data into the database, the searching becomes very tedious job for us. The performance will be very bad. It will take a lot of time to fetch the required data from the transactional table when the data is huge. Not only the searching, even the maintenance of data in the table will also become difficult. When we say maintenance, it's like archival of data, removal of data from the transactional table and copying the same data into archival table or secondary tables or historical tables. Suppose if it is sales, it is not necessary to maintain the complete data in the main transaction table. We need to maintain the recent data, maybe last 1 month or 1 year or 2 years, maximum of 5 years of data. That depends on maybe our sales return policy, exchange policy, warranty policy, etc. Suppose the products what we are selling in our shop or maybe outlet is having a maximum warranty of 5 years. In that case, we need not maintain the data beyond 5 years. Because we do not have any warranty, we do not have any support after 5 years. So a maximum of 5 years of data is required in our table, and that too, all the 5 years of data is not required in our main transactional table. In our main transactional table, we require the data which falls under exchange policy or return policy, which will be a maximum period of 10 days or 30 days or 60 days. So only 1 month data or 2 months data, or still beyond that maybe 1 year data is required in our main transactional table. Rest all other data can be moved to our historical table. If there is any warranty, it is not immediately retrieved. It is not required immediately. We can wait some time. Maybe the record is coming after 5 minutes. There is no issue because very few customers will come back for this warranty support. Very few products will go damaged. Not all the products will go damaged and everybody will come for the warranty. Even if everybody is coming, still we can ask them to wait some time. We can take some time for processing. But for exchange, return, it has to be immediate because it will be within 5 days or within 10 days or within 30 days. It has to be retrieved immediately. Along with, we have to serve our regular customers as well as the customers who have come for exchange or return. So that is where we require lot of performance. So we require this data in our main transactional table. Rest all other data can be moved to our historical tables. So in that case, we need to archive our data on monthly basis or quarterly basis or maybe weekly basis. If it is telecom, it may be on daily basis or maybe hourly basis also. So when the data is archived, the main transactional table is having very less data. The historical table will have huge data, and when we want to archive from our transactional table, searching of 1 month's data or searching of 1 year's data will be very difficult. It will take very long time to identify out of crores of records or billions of records. In that case, the partitioned table will help us a lot, either for searching or for maintenance purpose, maintenance of data, either for archival or removal or deletion or truncation or drop, whatever it is. So in such type of cases, we go for partitioning on a table. Means one table will be partitioned into multiple partitions based on the requirement, based on the type of partition we have chosen and the number of partitions we have chosen while creating the table. But one thing we need to remember, the non-partitioned table cannot be partitioned directly later point of time. We have to create the partitioned table at the beginning itself. In the beginning itself, we have to decide whether we want a normal table or partitioned table. If we need a partitioned table, we have to create the partitioned table in the beginning itself. Once the table is created and the data is moved or inserted into the table, later on the non-partitioned table cannot be partitioned again. So that facility is available from 10G onwards. The non-partitioned table can be partitioned using redefinition, dbms_redefinition package, but it will take long time. Instead of that, creating a new table and copying the data from old table to new table will be faster than redefinition. So at simple, to make the process as simple, create the partitioned table in the beginning itself. So instead of redefinition or redefining the table non-partitioned to partitioned later point of time, it's better to create the partitioned table in the beginning itself. So when we create a partitioned table, whatever the type of partition it is, one table will be divided into multiple partitions and each partition will be acting as a separate table for us. We can search within a single partition itself. It is not necessary to search in the entire table. When we have partitioned table, we can search within a single partition. If we know in which partition the data is available, then we can search within that particular partition. We can create index specific to one partition. We can create local indexes. One index will be treated as multiple indexes for each partition. Each partition will have a local index like that. Or we can go for one entire global index. Or even the index also can be partitioned. When we create local index, more or less it's something like index is partitioned based on each partition. or we can physically or directly partition the index also. So whenever we have huge number of records in the table, it's better to create partitioned table. When the inflow of data is huge, instead of storing into a normal table, it's better to store the data into partitioned table, so that the future maintenance of data becomes easier, even the storage of data will be easier, and selection, retrieval of data will also be easier, or maybe modifications of data will become easy. Now let us see what are the different types of partitioning mechanisms are available. What are the different types of partitions available? We have range partition, list partition, hash partition, composite partition, interval partition, reference partition, system partition, virtual column partition, and interval reference partition. So originally in older versions, first range partition is introduced. In the next version, that is, I think it is in Oracle 7, in Oracle 8, list partition is introduced. 8i, hash partition is introduced with one option. 9i, the same hash partition is enhanced with another option. Next, in 10g, composite partitions are added. Composite partitions are nothing but sub partition, that is, partition inside another partition. So when we have partitioned table, we can create sub partitions within a single partition. Even one partition can go very huge if it is telecom domain kind of domains. So within that we need sub partitions again. So even if you go for daily partition in the telecom domain, it will be billions of records. So in that we need hourly sub partitions again. Even for hourly partition also it will be huge number of records. So that is where we use composite partition. Interval partition, reference partition, system partition, virtual column partition, all these are introduced in 11g release 1. Before that we do not have this interval, reference, system and virtual column. Interval reference partition is added in Oracle 12c release 1. This is the combination of interval partition and reference partition. Together was not there in 11g, that is addressed in 12c. That partition is made available in 12c. So this is the latest partitioning mechanism or partition type which is added in 12c. So up to 12c we have totally 9 types of partitions. So we can partition a table or we can create a table with 9 different types of partitions. So out of which, except in case of interval partition, in all other cases we need to choose the partitions while creating the table. We need to define the number of partitions and the names of the partitions also sometimes. Only in 1 or 2 cases we can specify only the number of partitions. The names will be decided by the database itself. Rest all other cases we need to decide or define the number of partitions as well as names of the partitions. The partitions have to be created by the developer manually. But in case of interval partition which is introduced in 11g, the partitions will be created automatically. That is the major advantage of interval partition. While creating the table we need to specify one base partition and the partitioning key. Based on the partitioning key, automatically the new partitions will be created whenever the new data arrives. That is the beauty of interval partition. The same thing is available in our interval reference partition as well. So when we say interval reference partition, it is not reference interval, it is interval reference. Interval is the base partition and reference can be subpartition or first interval and then reference kind of partition. So in case of interval partition, the partitions will be created automatically, except in case of interval partition. In other cases, the partitions will not be created automatically. We have to choose the partitions. We have to define either the number or number and partition names by the developer itself or the DBA or maybe by the user. Now let us see each partition one by one. Range partition. Originally, the range partition is introduced for numeric columns and date columns, for numeric data, number and date. Later on, it is extended for other data types also. When we have range partition for number and date, to support character data, they have introduced list partitioning. So originally, list partition is only for character data. List partitioning is for character data initially. So later on, it is extended for other data types also. Then hash partition. So hash partition is introduced in 8i. So when it is first introduced, we will specify only the names of the partitions with number, like 4 partitions. I will give partitions as P1, P2, P3, P4. Means number is decided and names also I will give. So I don't define any partitioning mechanism over there. Just number of partitions I will define with names. And in 9i, it is extended. We can define only names. Partition, number of partitions 4. We need not define the names for that. Names will be defined by the system itself automatically. See, at present, the range partition, list partition and hash partition can be defined on number column, character column, varchar, date, timestamp, interval, literal. On any of these data types, the range partition, list partition and hash partition can be created. If it is range partition, we can create a max value partition. If it is a list partition, we can create a null partition. That is not possible in case of hash partition, because here we specify the number of partitions, no default partition. So when we say max value partition or null partition, this is the default partition. When the value does not match to any of the partitions, it will go to the default partition, which is the max value in case of range partition and null in case of list partition. So there is no default partition in hash partition. So these were the 3 partitions which were available till 9i. In 10g, added composite partition, which is sub partition. When the data is huge, high volume in each partition, then we need to partition the partition itself. We need to sub-partition the partition again into smaller pieces. That is where the composite partition came into picture. But all the combinations are not available. So till composite partition, we had only range, list and hash. So within these 3 only, we need to identify the combinations. But in 10g, only 2 options were available: range list and range hash. Actually, originally the composite partition was introduced in 8i itself, not full-fledged with very complexity. 9i they enhanced a little bit, 10g they made it as very simple. So range hash was available from 8i, range list was available from 9i. And remaining combinations they added in 11g. Range is valid in 11g. List range, list hash, these combinations are added in 11g. Hash range, hash list, hash is not available in till 11g also. Since interval partition is added in 11g, interval hash, interval list, interval range is added in 11g, Oracle version 11g. Interval is not allowed, because interval must be the base partition. Within that we can go with hash or list or range as subpartitions. Interval cannot be the subpartition. So these are the combinations which are available in composite partitioning. Next, after composite in 11g we have 4 partition types are added. One is interval partition, where the partitions will be created automatically, and the data types allowed for interval partitioning is number, date, timestamp and interval literal. Only with these data types we can create interval partition. Mainly number and date or timestamp also. Character, varchar, these data types are not allowed for interval partitioning. Next, so in interval partition we need to specify a time interval. Suppose we need to create a base partition like monthly partition or yearly partition. When we say the time period as year, when we insert 2015, it will go to one partition. 1st Jan 2015. If you insert 31st December 2015, it will go to the same partition. As of now, only one partition is there. When we enter 1st Jan 2016, partition is not there. So it will create a new partition for 2016 and it will insert into that partition. When we insert 1st Jan 2017, again one more partition will be created and this record will be inserted into that partition. So whenever new data coming in, the partitions will be created automatically. That is interval partitioning. Next, reference partition. This partition is introduced in 11G to support parent-child relationship, that is foreign key. See, when we create the partition on parent table will be partitioned, but the child table will not be partitioned. If we want partitioning on child table, we need to create partitions manually on the child table also with the same partitioning mechanism. But when we have this reference partition, if the parent table is partitioned, automatically the child table records will be partitioned with the same mechanism whatever we have used in the parent table. That is the beauty and advantage of reference partition. That is, when the parent table is partitioned, the corresponding child table, that is the corresponding foreign key column in the child table will automatically be partitioned with the same partition key. That is, foreign key will be referencing to primary key. So we will be partitioning the parent table based on the primary key column. Accordingly, all the values in the child table will be going to the same partition. Means child table will also automatically partitioned and the values will be segregated into the same partitions automatically. That is the advantage of reference partition. System partition. When we have hash partition, we can only specify the number of partitions. We do not know where the values are going and residing, in which partition the data will be stored. We do not have any control, but the data will be equally shared among the partitions. Record 1 will go to first partition, record 2 will go to the second, record 3 will go to the third, record 4 will go to the fourth partition, record 5 will go to the first partition, record 6 may go to the fourth partition, record 7 will go to the third, record 8 may be 2. So like this, over a period of time, all the partitions will have equal number of records, but we do not have any control which record will go to the which partition, like that. The storage will be very easy, inserts will be faster, the search will be slow in case of hash partition. That means we do not have any control in that. In that case, the system partition will help us. We can define, like hash partition, we can define the number of partitions with the names also. It's like hash partition only, but the name is system partition. So we have two options here. We can define only the number of partitions and names can be left to the database to decide, or we can define the number of partitions along with names like hash partition. Both the ways we can create the system partitions. But while inserting the data into the system partitioned table, we have to explicitly specify the partition name. If we do not specify the partition name, it will throw an error. That means we have the control into which partition we are going to insert the data. So this inserting mechanism we are leaving to the application layer, to the UI. The application layer will decide, okay, first 100 records will be inserting into partition 1, next 100 records will be inserting into partition 2. So we are leaving the decision to the application layer. Instead of the database is taking the decision, the application layer, we are leaving the decision making to the application layer. You decide where you want to insert, which partition you want to insert the data. One way there is an advantage, in another way there are disadvantages here, because every time we insert we have to specify the partition name, which is risky, which is tedious job for us. And for update and delete we need not specify the partition name, but it will go through the full table scan. If you specify the partition name, then it will be faster, otherwise it will work but it will go for full table scan. But facility is there, the usage is up to the developers. Next, virtual column partition. Since virtual column is added in 11G, we can also partition the table based on the virtual columns. Virtual column does not store any data in the database or in the disk. Virtual columns data will be derived on the fly. Whenever we select, the data will be derived for that particular column. But partitioning is possible on virtual column also. Next, interval reference partition. We know that in case of interval partition, the partitions will be created automatically. See, when we partition the table, when the parent table is partitioned based on interval partition, based on the primary key, the partitions will be created automatically for the parent table, but the underlying child table will not have any partitions. If we want to create partitions On the child table also it will be very difficult for us. Either we need to create interval partition on the child table also, or create the partitions manually. This restriction was addressed in our latest 12C release 1. We can have interval reference partition. We can go for interval partition. We can use interval reference partition on the parent table and we can relax. The underlying child table of this parent table will be auto partitioned based on the foreign key column. When the parent key is partitioned, the foreign key will automatically be partitioned because of this interval reference partition. So whenever a new partition is created, a new partition will be created for the child table also. That is the advantage of having interval reference partition. So this is the overview of types of partitions what we have in Oracle. Now we will see each partition in detail. Before that, what are the other operations are possible on the partitioned table? We know that the partitioned table must be created in the beginning itself before loading the data. The non-partitioned table cannot be made as partitioned table in the future after inserting the data, but that facility is there starting from 10G using dbms_redefinition package. We can go for redefinition, facility is there, but this will take very long time. So instead of that, it's better to copy the non-partitioned table into a newly created partitioned table. But both the options are there, but it is always better to create the partitioned table in the beginning before inserting the data. And once the partitioned table is created, what are the operations that are allowed or modifications that are allowed on the partitions of a partitioned table? These are the modifications are allowed to the partitions of a partitioned table. 1. Add partition. Partitions can be added. A new partition can be added in the table, but all the new partitions will be added at the high end. That means at the end of all the existing partitions. After all the existing partitions, the new partitions can be added. New partitions cannot be added in the beginning of the table or beginning of all the partitions or middle of the existing partitions.